in this part now, we are going to talk about physical quantities. So we're going to talk mainly about 2 points. These quantities now, they can be classified into basic quantities and derived quantities. And also these quantities can be divided or classified into scalar quantities or vector quantities. Okay, this point now that we're going to start by, we're going to talk about basic and derived quantities. Here we have 7 basic quantities. What are these quantities? For example, now temperature is a quantity, that we can measure it, that we can give a number to how hot something is. So temperature itself is a quantity. And when we describe this quantity now, we describe it by a number. So we cannot say just something is hot or cold. Maybe it's hot for you, but it's not cold for another person. So that means now we need to give numbers. We need to describe this temperature by using numbers. When you use these numbers now, we need to give units. So when I say the temperature is 5 what? 5 kilogram? 5 what? 5 meter? So we have to give it a specific unit. So the SI unit, if temperature is what? Is Kelvin. So temperature is a quantity and its unit is Kelvin, SI unit. It has another units like Celsius and other units, but here we are talking about SI units, which is the International System units. So that means temperature is a quantity and Kelvin is its unit. And it's simple as what? K. Another basic quantity is distance. How we measure the distance from a city to a city, the distance from place to place. We describe this distance by saying numbers, 3, 4, 5, then what? We use a unit. Here we use meters, but we can use kilometers, we can use centimeters, but what is the SI unit? It's meter. So that means we describe the distance, which is a quantity, by a number and a unit, which is what? Meter, and we write it as M, a small m. Okay, electric current, also this is now basic quantity, and its unit is what? Is ampere. So that means when I say what is the electric current in this room? So that means, oh, what electric current the mobile needs. So that means you need to describe that by saying 5, 8, 20 ampere. Okay, which is what? Capital A. And also for time, when we talk about the time, we describe the time. So time is a quantity, and when we describe it, how much time it will take, the trip will take, how much time will the school take, how much time. So that means now when you describe the time as a quantity, you describe it by a number, you give it 5, then you say what 5? You can say 5 hours, 5 days, 5, it's still yet units for what? For time. But what is the SI unit, which is the International System units? It's second, and it's a small s. Okay, now amount of substance in chemistry, when you say how many atoms in a substance, how many atoms, how many molecules, we cannot say 3 atoms or 3 molecules because atoms are very small. So you have to say them by moles. Okay, how many moles are there? And again, study it in details with chemistry. So that means amount of substance is also mole and mol here. For mass, what is your mass? You say 50, 60, 70, 60, what? Kilograms. So that means you use the unit kilograms to express the quantity of mass. And this one here is kg. Last one, which is intensity of light, or you call it luminous intensity. And it is what? Candela. So these ones CD here. So that means these ones now are 7. So how many? 1, 2, 3, 4, 5, 6, 7 basic units. And these ones are the main units in physics and the main quantities. So you need to remember these ones are called basic units and these ones are basic quantities. So quantities is in general, but unit is to describe the quantity, by using also what? Numbers. Okay, this is now one side of the quantities. Is there any other quantities? If these quantities, which called basic quantities, only 7. Okay, what about the other quantities? speed, velocity, acceleration, displacement, for example, and power, force, these other quantities. Are they basic? No. Only we have basic quantities here, 7, and that's it. Okay, what about the other quantities? Any other quantity rather than these 7 is called derived quantity. Okay, what are derived quantities now? What are derived quantities? Derived quantities, and why do we call them derived? Okay, I'm gonna give you an example here. If we are talking about the speed, so speed, it equals distance over time. It equals distance over time. So that means now the speed equals, what is the unit of distance? It's meter. It's what? It's meter. So you write m. Over time, what is it? Second. So you write here what? Second. So that means the speed unit, it is what? It is meter per second. Okay, meter per second, is it independent unit or it is a unit that it was derived from the basic units? No, it was taken from the meter here, and it was taken from the second here. So that means these 2 units as basics, they gave us what? They gave us the unit of speed. So the unit of speed is derived from the basic units. So speed, or the unit of speed or quantity of speed, is called derived quantity. And its unit is called derived unit because it was derived from other basic units. And you have another examples. For example, area now, what is its unit? Is meter squared. So where come the meters squared? It came from meter times meter. So that means it came from basic quantity. So area is also derived quantity. Acceleration, force, whatever. So all other power, pressure, all these other quantities are derived because mainly they are derived from these basic units. So we explain now what's the difference between basic and derived quantities in physics. Okay, now we'll go to the second part. What is the second part now? It is a scalar and vectors. A scalar and vector. Okay, what is a scalar quantities and what is vector quantities? Okay, if I'm talking about, for example, here, if I'm talking about temperature, if I'm talking now about temperature, and if I ask you now, what is the temperature in your room? What is the temperature in your room? You're gonna tell me, regardless of the unit, you're gonna tell me the temperature is 30 degrees Celsius. So when you told me the answer, when you gave me that the temperature is 30 Celsius, did you need to give me a direction? No. So you gave me only a number and a unit. And the answer was fully understood. So in this case now, we call the quantities that are expressed by only the number and the unit, we call them scalar. So when I ask you another question, when I ask you what is your mass, and you say my mass is 70 kilograms, that's enough. So that means you gave me a number and you gave me a unit. So this quantity of mass is a scalar. When I tell you what is the distance between Mecca and Jeddah, and you tell me it is 80 or 100 kilometers, that's enough. So that means you gave me a number and a unit. So that means the length is what? Is a scalar quantity. So these ones now, the distance, the speed, the power, the energy, the work, in general, and other quantities, in general, these quantities are what? Are scalar. So that means you need a number only to explain them. How many calories in joules, or what is the energy in joules in one chocolate? So when you express it now, you say how many joules or how many calories, and you say the unit and the number only. So that means in this case, the energy is scalar, not vector. Okay, but what about now vector quantities? For example, now I'm going to talk about force, and the unit of force is Newton, and it's derived unit. Okay, now why force is vector quantity? Why? So if I have a box here, and I tell you now that push this box by a force 5 Newton. Push this one by 5 Newton. Okay, you will push this box by a force, for example, you know what is the force of 5 Newton, for example, here. But now when you come to push this box, will you know which direction you need to push it to? Maybe I mean to the right, but you come to push it to the left. Maybe I mean up and you come to push it down, right? So that means force now, a number alone is not enough to explain it. So that means it needs to be what? Explained by direction. So that means now, I tell you now, you need to push this one now by 5 Newton. Then I tell you what? Left or right. Then I give you direction what? Left or right. So that means any quantity, any physical quantity, and these ones all are physical quantities, any physical quantity that is explained by a number and a unit alone, and no need for a direction, we call it a scalar. And any quantity that it needs direction to be explained, it is in this case what? Vector quantity. Okay, we're going to explain now here, in this case as example also, what's the difference between distance and displacement? Both of them, they describe the length. But now what's the difference between distance and displacement? Distance, it measures how long have you moved, regardless of what's the direction, because it is a scalar. Because it is what? A scalar. So for example, now my home is here, and I moved this direction 50 kilometers. Okay, then I moved back. I moved back from this direction to this place and I stopped. I moved back 30 kilometers. So now, in this case now, when I'm talking about a distance, distance is talking about the whole trip. How long have you moved? So that means in this case, the distance in this case is exactly what's 50 plus 30. So that means you moved 80 kilometer distance. Because distance now is not related to the direction, whether is it left or right, forward or backward, is not related because it is a scalar quantity. But now when we come to displacement, how can you describe this one now as a displacement? Displacement is vector quantity, and when it is vector quantity, that means it is sensitive to directions. And in directions, in general, in math or physics, if one direction to the right and the other direction opposite to that direction, so these opposite directions, one of them, we classify it as positive direction and one direction as what? As negative. So when we explain or when we study the vector quantities, we have to be careful about what? About directions. So that means here, if we describe the right direction as positive, that means the left direction now will be what? Will be negative. So that means now, if you want to find displacement now, you add these values, but with their given signs. So that means the sign here is positive and the sign here is negative. So that means when you add now positive 50 with negative 30, you're going to get that the displacement is exactly what? 50 and negative 30, it's going to be positive 20. Positive 20. So that means the displacement here, it is 20. But what does the 20 here in this example? It means exactly the distance between the final point and the initial point. So what's the distance here between the final and the initial point? The difference between them is 20 kilometers. So that means this 20 kilometers represent the displacement, while the 80, which is the whole trip, regardless of the directions, it is what? Displacement. So you understand now the difference between scalar and vector, and an example of them as distance and displacement. Another example now, we're going to take another example now with the speed and also what? Velocity. What's the difference between speed and velocity? Speed, it equals distance over what? Over time. Okay, but velocity, it equals displacement. Displacement over what? Over time. So as you see here, that means here it used displacement. So it used vector quantity. So the velocity is vector. But here now the speed, as you see, it used distance here. So the distance here, it is scalar, so speed is what is scalar. So if you say my speed or my car's speed was 100 kilometers per hour and you stopped, in this case you gave me a number and a unit. In this case, I know that you mean the speed of the car, not the velocity of the car, because you didn't mention a direction. So now, when you in front of the driver of a car, there is a speed meter or velocity meter. It's called a speed meter. Why? Because it gives you the speed in a number and in a unit, but it doesn't give you the direction. So that means it is a speed meter. It gives you the speed. So that means if you are moving with a speed 100 kilometers per hour, and you don't mention what direction you are moving to, in this case, this is a speed, not velocity. But if I say if I'm moving in 100 kilometers per hour north, in this case, I'm giving direction. So that means in this case, it is called what? Velocity. Again, vectors or vector quantities are sensitive for directions. And when there are opposite directions, that means the signs of the vector quantities will be opposite to each other. One positive, one negative. Then you add them to find the resultant quantities. Okay, so that means now here we understand how to find the resultant unit when you add either vectors or scalars. Scalars just you add them regardless of the direction, but vector you give one sign positive, one sign negative, then you add them, or you find them by Pythagorean. If they are 90 degrees, the distance between them, to find the resultant, and we're going to study that in details with vectors in math. Okay, that's for now. So we understand now, we finished understanding what are physical quantities. We said they can be classified by either basic or derived quantities. And there are 7 quantities that are basic and other quantities are derived. And they are called derived because they are driven from the basic quantities. And we say also physical quantities, they can be classified as scalar and vector quantities. And scalar quantities, they are explained only by number and units, and they don't need direction, while vector, they need a number and unit, and also they need a direction. Thank you for that.